Thank you guys so much for being here. This is actually the most important talk of the day. And it's not just because we're all going to go drinking afterwards, but because this talk is about saving lives. In a single month, collectively, internet users are waiting about 10,000 years just for pages to load. That's a lot of lifetimes. Now, I know this is an HTML5 conference. We've beaten the load times dead horse to death. But what no one talks about in the hallways out there and in these rooms is who's really responsible for about half of those 10,000 years that internet users waste every month. And that's the little banner ad at the top of your page. That's right, the synchronous ad that has to load before anything that the user really came for is going to arrive on the page. This is a talk about saving lives. So in a moment, I'm going to show you a short documentary. It's actually really short. So short, there's not really time for character development. So I'm going to go ahead and introduce our characters. It's a tale of two ads. So we have a synchronous ad and an asynchronous ad. Now, we've called them synchronous and asynchronous to actually disguise their true identities. Because what you're about to hear is not pretty. So let me ask you guys, which one do you think is the good guy? We got asynchronous. Anyone else? Well, it was actually a trick question, because all ads are evil. They're not just evil because they spam our users. They're evil for the absolute worst reason anything on a web page can be evil, and that's that they make a hell of a lot of requests, internet requests. So let me show you. So this is a snippet that you'll put on your page here for double click. Can you all read that? I'm just kidding. You put that on your page, and this document.write here, that's like a macro that expands at runtime. It like blows up like a helium bomb, and it produces all this. All that stuff goes into your web page, and that's okay. It's just HTML, right? But if we do a search for src equals, we end up with about 22 network requests from that one ad. Once again, this is a talk about saving lives, and I'm going to show you how to do that. Now, do you guys know what a synchronous ad is? If I say synchronous ad, or, I mean, we all know what a synchronous script is, right? In the HTML, it's just a script tag. You guys with me on that? Yeah? So a synchronous ad, scripts can document.write other scripts, and they can document.write anything as they do their macroness. A synchronous ad says to the browser, the browser is parsing the DOM, it says stop everything you're doing right now. I need to make 22 network requests and load 12 remote scripts in serial before you show the user anything. I was really surprised when I found out about this. I mean, I come from a UI background where we're taught about how to load scripts asynchronously and insert them into the DOM like good network citizens. But no one talks about these scripts, these ads that are using document.write. All right. Let's go to the documentary. All right, the internet in here is actually really speedy, which is working against me. So here's a documentary. You ready? So we have our two characters. Two ads walk into a browser. What's happening there? Okay. So as you can see, I mean, this is really fast internet. The ad on the left has to load before we can see the content on the left. And that's it. That's a documentary. Let's go behind the scenes, though, and see what's going on. So this is our synchronous page. Here's our HTML. So here we have our ad. We document.write inside the div here. And then we have our content. So far, so good. Now, what we're loading here in the slideshow, this is artistic. These are the artistic gymnast medal winners from the past Olympics. Let's see where they turned out in this competition. All right, there they are. They're kind of mediocre here, kind of halfway down. See what came in above them. Oh look, double click got the gold. All right, now let's look at the other character, the async page. First of all, where did our artistic gymnasts come in this time? Oh, look at that. They're first. This is what the user came to see, and this is what you're giving them right away. How did we do this? Well, the short answer is magic, a lot of magic. The long answer will come, and that's what the rest of this talk is about. So here's our ad. Where did the document.write go? At the bottom of the page, we're loading this special library called PostGrab, which is a form of asynchronous document.write. That's right, asynchronous document.write. And then we're writing to our ad the same HTML that we document.wrote on the synchronous page. All right. So we all know that load times matter. Not just load times, but writing asynchronous also lets us do something that we can't with regular document.write. We can refresh an ad. So say we have this slideshow here. We have Intel at the top. And then we have Lawrence Fishburne. Oh, and a new ad. And this isn't an iframe. Here's our ad. Let's do that again. So it's actually rewriting the DOM there. But the ad is just using document.write. We didn't change anything. We didn't go to the ad server and say, hey, listen, you got to change your document.write for document.create element, append child. So we know all these numbers. We know that load times matter, and we know that this is something we need to do. We need to make ads async. It's the way of the future. A lot of big names are interested in making ads async, including Google. All of our clients at Krux, people like Wikia, New York Times, Wall Street Journal, Reuters, are all interested in this problem. So wait, so why doesn't everyone just do it? And that's a good question. The problem is document.write. Are most people here familiar with how document.write works? The fact that it has to be in the page? I see a lot of people nodding. Awesome. So a few people tried, or started to, a couple years ago, try and override document.write and come up with an implementation that was asynchronous. And there's been a lot of improvement since 2 years ago. I'm going to tell you about this document.write and show you some of its idiosyncrasies. Then I'm going to talk about a few approaches to making it asynchronous. And finally, I'm going to talk about some products that use those approaches and the pros and cons of each. So you'll have something to go home and save lives with. I had a lot of fun writing these little helper programs that I'm going to use to demo some of this stuff. HTML, turning HTML into the DOM, I mean, that's pretty straightforward, right? You see a tag, so there should be an element. If there are things inside the tag, those become child nodes in the DOM. I mean, it's pretty straightforward. I'm here to tell you in the next 5 minutes that it's not. It's HTML. HTML is kind of like the matrix. The matrix before Neo takes the red pill. Everything kind of looks washed out, black and white. The DOM, however, DOM is like the matrix on the red pill, and we're going to see just how far the rabbit hole goes here. So this looks normal. We know about T-body elements, kind of these implicit elements that crop up. What if we ask it to do something ridiculous? So I don't know if I've made it clear, but on the left is HTML. On the right is what it would produce if we document.write what's in here. All right, sometimes we forget to close things and we're naughty. This looks fine. The DOM gets closes it for us. But what happens if we start writing outside here again? The I element is almost echoed. And if there are attributes, they get echoed too. Now, not all browsers behave like this. This is the more modern ones. If you take something like this, which is complete, I guess they call it tag soup. It's improperly nested tags. Modern browsers will produce a tree that looks sane, where if you're my child, then I'm your parent and I have multiple children. IE actually tries to be, or IE7, IE8 actually tries to be, tries to represent this in the DOM and actually creates DOM soup. So just because I'm your parent doesn't mean that you're my child, for example. So in this case, P could have I as a child, but I has P's parent as a parent. Anyways, why is this important? I'm trying to instill a problem, instill in you an understanding of the problem and why it's hard. We're not all the way there yet. So that when I show you the solution, you guys are going to be like, oh, wow, thanks, Derek. Let's do a simple doc.write here. So if you document.write something, inside a script, the script is actually, if the script is inline, it actually gets executed right then and there. So you have to be careful. If you're going to emulate document.write, you have to get this nesting right. Even more interesting, if you load a remote script, the writer actually delays the continuation until after the script is loaded. Now, all remote.js does is it writes this div remote. So if I were to document.write a remote script and then try and use it down here, some function like remote, it wouldn't exist yet. Thank God. Because if the JavaScript thread actually paused for the script to load, then the page would freeze up. So the script is allowed to exit. In this example, we note that document.write is actually happens immediately. So here we're going to write a div with ID div1, and then immediately we can set its InnerHTML to something interesting and creative. And ads actually do this a lot. They'll document.write a div, and then just to have a place to hang things, they'll start appending, setting InnerHTML, and creating the visual representation of the ad in the DOM. All right, so now for the solutions. The first, there are two parts to the problem of document.write. One is getting the flow right, and by flow, I mean, a script can call document.write, and document.write can create script tags. And everything, if you document.write a script tag, everything after that document.write has to be delayed until the script executes. So you have to get this nesting, this tree of scripts and writes. You have to get it right. That's the problem of flow. Once you get that right, then you just have a sequence of static HTML that doesn't contain any scripts because you've evaluated all the scripts. You can throw away scripts once they execute. They're not really needed in the DOM. So the next problem, that of putting these rights, having the rights append things to the DOM, is actually the hardest problem. And the reason for that is just that the way the parser works is so complicated. It's hard to emulate it programmatically. But people have tried, including Krux. Our first two iterations of an async writer were parser based. And what I mean by parser based is as a write comes in, there's some HTML. You parse it into tokens. Say, here's a start tag. Say it's a div. So I'm going to create a div and put in the DOM. And then before that tag closes, I see a paragraph tag. So I'm going to create a paragraph element and make that a child of the div using a pen child. That works fine until it doesn't. And we really found that there were too many ways that could go wrong. So here I have an example. On the left of the parser and DOM approach. It works really well for doing things immediately, as you can see. We document.wrote this and immediately added InnerHTML, and boom, it worked like a charm. But the way that this writer decides to nest DOM nodes is dependent on a parser that's written in JavaScript. So it gets stuff like this. It gets that right. It's not, I'm expecting those P's to be side by side because P's are self-closing. But over here, the DOM is telling us that the div closes the P tag, document.write. Document.write is the final, has the final say on this, because that's what advertisers are expecting document.write to do. But this parser plus DOM approach is doing something completely different. And that's why ads break. For this, in this example, the parser plus DOM approach is Ghostwriter 11.6. So we found the parser plus DOM approach to be it just too hard. Too hard to rewrite what the browser does when it loads an HTML page. Now, the first thing people thought of, what would you guys think of if you had some HTML and you need to convert it into the DOM? What's that? Could you speak up? Make it well-formed. Okay, but you actually, we don't have control over that. It's the ad engine that's giving us some JavaScript, and they're terrible programmers. InnerHTML, yes. That's what I think that's what jQuery uses when you pass it some HTML and say, hey, put this in the DOM. InnerHTML is amazing because it's asynchronous. You don't have to interrupt anything to use it. And it does exactly what document.write would do. So remember, we've gotten rid of the scripts already. We're just concerned with writing things that don't contain scripts anymore because we figured out the flow. InnerHTML is perfect except for one thing. It only works for the first write. The other 130 or however many your ad makes won't work. And the reason for that so this is really the first naive approach. Let's just do plus equals. We want our paragraph to contain an I element, right? Now let's look at the inner edge. Actually, let's just look at the div. And it doesn't. It didn't do what we wanted, and the reason is that InnerHTML is kind of final. Let's set the InnerHTML once again to a paragraph. So if we look at our InnerHTML, It's already closed it for us. So plus equals isn't going to work for doing multiple writes. On top of that, something to note here is that if say we had a pixel in our ad, this is trying to pick up, trying to load this pixel, that, say, notified the ad server when the impression had impressed the user. And then we try to, append to that our I element. It actually loads the image again, and that's because, as we know as programmers, plus equals is a get, a plus, and then a set. So you're wiping out the DOM and reconstructing it. This just will not do. So the next generation of document.write emulators, write capture comes to mind, qubits, OpenTag. They said, well, listen, we're just going to buffer everything. And at the very end, we'll just do an InnerHTML. And that gets the structure perfectly. That's exactly what you want from a structure point of view. The problem is that, and here we have an InnerHTML writer. Problem is it doesn't get this right. 1 second. It doesn't write immediately, right? Because it's buffering. It's waiting till the end, till all the document.writes have finished, because it knows that afterwards I'm gonna keep document.writing other stuff. It knows that I'm going to keep document.writing, and if it used plus equals, this P would be beside the div. But because it's waiting until the end, it knows, it uses InnerHTML, and InnerHTML figures out that the P goes inside the div. But not only is the div not available here, we actually broke the ad. The P can no longer be written because div1 is null. This sucks. And this is, ads do this all the time. They write something and then they want to append children to it. They want to set attributes. So I know I'm being really negative, but if it weren't for Digital Fulcrum's Ghostwriter, for write capture, for qubit and OpenTag, Krux wouldn't have accomplished what we have. And that's what I'm kind of pretty excited to show you guys. So our solution is called PostGrab. So PostGrab here is in the upper right. So I'm going to turn diffs on so we can see where things screw up. So as you can see, PostGrab gets the immediate part right. PostGrab uses InnerHTML, but it does so in a way that is streamable. It figures out the plus equals, and I'll show you how it did that. It also gets all the nesting right. Here's our P with a div that not many people know about. Parser plus DOM gets it wrong. Ghostwriter. Actually, parser plus DOM is write capture 2. Ghostwriter gets it wrong. InnerHTML gets it right, but once again, that's because it was buffering. PostGrab gets the correctness and the immediacy. Now, how does it do that? I'm going to show you the algorithm so you can understand, because it's actually pretty simple. All right. I had fun thinking of this like a proof by induction. Do you guys remember that from school? Where you say, this is the base case. For the first write, we're going to use InnerHTML. And then assume magically we can do it for the first n writes. We can write perfectly. How do we do the n+1th write? So the way we do it is this context. We keep track of this context of everything that's been written so far, but we strip out the text and we strip out the attributes, because they're not really needed to understand what the DOM should look like. Here we have what we want to write next. So we open a span, then we have this image. We don't want the image to fire twice. Then we want to write some text, have a paragraph, some other text, and close the span, and behind that, write some more. Got it? So here's what we want it to look like. This tree down here is just a fancy way to look at the DOM. All we're doing here is InnerHTML. How do we get the next right? The answer is we take this context and we append it, prepend it, sorry, to what we want to write next. Now, the yellow nodes are nodes that we've already written. And the other nodes are new nodes. We know that if we see a text node, that it's a new node. And maybe we've inserted an attribute into the context that tells us that this image is a proxy for the image that's over here. Then what we do is we look at the parents of the elements. If that parent is a proxy for an element that's already been written, we move that child underneath, we append that child to the actual node in the DOM. Does that make sense? So in doing this, we've been able to see some amazing differences in how ads are rendered asynchronously. You guys have any questions about this? Does this make sense? The question was, how are we buffering? Yeah, just in a JavaScript variable. I don't know, maybe that was too much of a simplistic answer. Actually, this is just a string. And then we use regular expressions to just take out the attributes and take out all the text nodes. There's a gentleman in the front here in the nice shirt. So the question was about how do we put the attributes back into the DOM? Yes. Okay. Well, we don't. We didn't take them out in the first place. These, as you can see, the attributes are there. We just keep around a copy. We only keep around, the only thing we care about what's been written before. We want to give some context to the new write so that we understand where nodes fit in. And InnerHTML is going to tell us that. So this context is just a string. It's just the bare minimum we need to keep track of to let InnerHTML know where we are in the writing process. So listen, I'm going to leave you with some resources. Some links to all the things that we talked about. Just to refresh your memory, we talked about how horrible it is. I mean, people talk about blood pressure and they talk about, you know, heart problems, but no one talks about banner ads. Then we talk about the idea of making document.write asynchronous. And we looked at a couple approaches for doing that. InnerHTML, and parsing and inserting things into the DOM. And finally, we introduced a new library into the mix called PostGrab. Now, all of our clients are using this right now. We've probably delivered about 100 million tags since the beginning of this talk to viewers of NBC Universal, Wikia, New York Times. This is battle tested. There's the GitHub repo. We'd like you guys to give it a shot. If you find bugs, let us know. Our company is really behind this product. It's the core of a lot of things that we do. Yes? Oh, geez. Is it free to use, and if so, how do we make money? That's like the classic startup question. It is absolutely free to use, MIT license, really friendly support staff. We make money off of a whole bunch of other things. Krux is in the business of helping publishers manage their data. So this product is actually part of a tag management solution. Tag management is kind of like a content management system for snippets like Google Analytics, ads, all kinds of pixels. So this is the core of our tag management solution. Our tag management solution is just one part of what we do. This project's been closed source for a couple of years, but we decided that we want to get the word out there and get people using this. And yeah, hopefully you'll like it. Well, listen, I had a lot of fun, and yeah, let's go drink something. Thank you very much for your time.